Okay, so this mini lecture is going to look at some ideas and some problem-solving ideas with motion, specifically a player of motion called displacement. And we're going to contrast that displacement to distance. So we're going to look at the difference between distance and displacement. All right, so these are very similar concepts. They answer the question of motion of how far did an object travel? So if we're interested in how far or where did something end up, we're going to start thinking about, well, am I interested in the distance it traveled or am I interested in the displacement? They both answer the question, how far? So what is distance? Well, distance defines how far in terms of what we call the total lengths. So adding up how far an object is moving, and just keep adding it. Doesn't matter what direction they're heading. So there's no direction element. We don't care. We just keep adding it up. So if an object travels 1 meter to the right, and then 1 meter to the left, and then 2 meters to the right, and then 4 meters to the left, we just add those numbers up. 1 plus 1 is 2, plus 2 is 4, plus 4 is 8. He traveled a distance of 8 meters. We just keep adding them. Distance is always positive. It's always a positive value because I'm adding up numbers. And if I keep adding numbers, and those numbers are simply defining a length of travel, a total length, I just keep adding numbers together, I stay a positive value. And it's important for us to be thinking about positives and negatives because they actually define something for us, as we learned in position. But with distance, it's a positive value. All right, so I might describe how far something went based on the total lengths. I also might be interested in defining how far something went in a fashion that we call displacement. Displacement is defined very different. It's the location of the object relative to where they started. It says, how far am I from where I began? So, how far relative to the start? It does not care about what path they took. I just want to know where I started, where I ended, and what's the difference? So the difference between where I started and when I ended. It's as if I started with my eyes open, then I closed my eyes and an object moved all over, and then I opened my eyes and it was somewhere else. How far did it go? Well, I have no idea how long it took in terms of the lengths it took, but I know it started here and ended here, and so it went that far. Mathematically, this is defined as taking our final position minus our initial position. So mathematically, displacement is defined as the change in position. Remember, position was defined as an x. A change, delta, is our representation of change. Our final position minus our initial position. Where did the object end? Relative to where it began. It is path independent. I don't care what it did like I care up here in distance. All I know is where I started, where I ended, how far away am I from that start point. How far away am I from that start point? Path independent. Now, if I'm interested in how far away I am, if I said I was 1 meter away, well, that's useful information, except my 1 meter to the right, my 1 meter to the left, and my 1 meter up, and my 1. We need some more information. We need to know the direction. So direction is important, whereas with distance, the direction was not. With displacement, it is. And when we have a mathematical quantity, a physical quantity, where direction is important, we have a special name for that, that's a vector. And so we want to keep in mind that displacement is a vector. It will always have a direction associated with it. All right, so by definition, those are our differences. In the next video or in a different video, we'll do some examples of that. Distance, just total lengths. Displacement, where I am relative to the start. And the key is to the start of the object's position. Not the world, but to the start. It's a vector. We have to pay attention to direction. How do those directions look? Well, just like with position, positives and negatives mean something for displacement. So that'll be our last piece in this video. So direction of displacement. Now I'm going to just define it in a one-dimensional horizontal meridian, and then we'll apply it to the other meridians. If I have a positive displacement, that means I ended to the right of my start by convention. If I have a negative displacement, I ended to the left of my start. So if I ended up right of where I started, my displacement is positive. If I ended up left of where I started, my displacement is negative. How might that look? Well, here's my world. Remember that, then we're going to use that one-dimensional world for a while. Let's say I set my origin here at x equals to 0. So positions to the right are positive, and positions, as we learned, to the left are negative. Now, if my object is located here at 1 meter, so that's where it started. It's at 1 meter, and we'll call this the initial position of the object. And it ended, after the motion that I cared about, at 2 meters. So my initial position was 1 meter, my final position is 2 meters. I ended to the right of the motion, of the location I started at. So I should have a positive displacement. Does that work out? Well, displacement is my final position minus my initial position. My final position is 2. My initial position is 1. This gives me a positive 1 meter. It's positive. It's to the right. So the math comes out giving us the direction that should be consistent with where we know as how we've defined it. What about if I move to the left? Let's say I start at position 2 and I move to position -1. So here's where I started, here's where I ended up. What is my displacement? Okay, well, delta x is our final position minus our initial position. My final position was -1, physical position in space, -1, minus my initial position of +2. So -1 minus a +2 has a displacement of -3 meters. I am 3 meters to the left of where I started. So our directions, our positives and negatives, tell us information about where we ended up in the world relative to where we started. So by convention, right is positive, left is negative, and similar to what we talked about before, up is positive, down is negative. East is positive, west is negative. And so those will be the conventions that we use when we problem solve. All right, so our definition, distinguishing distance and displacement. Good job.